right, so we have made it through the end of our series unit. So the next 2 days, today and the next class period, we're going to review what we have learned in our series unit because we've spent a lot of time on this, and this is a major portion of the BC part of your exam. It's almost half of the BC part. So the first thing that we did last semester when we started our sequences and series unit was we talked about convergence and divergence. So we started with sequences. Remember, sequences are a list of numbers that have a pattern. And if the limit as n goes to infinity of our formula is equal to L, and L is a finite number, something between negative infinity and infinity, then we say it converges. If the limit does not exist, then we say it diverges. So to determine if a sequence converges or diverges, we just use our top-heavy, bottom-heavy equal trick. So n plus 2 over 3n minus 1, that is equal, so my limit is going to be 1/3, so therefore we converge to 1/3. If I look at this one, the limit as n goes to infinity of -1 to the n plus 6, this guy is not going to exist because if we think about our sequence, when n is odd, it's going to be -1 plus 6, which would be 5. When n is even, it's going to be 1 plus 6, which is 7. So it's just going to alternate back and forth between 5 and 7, which means it doesn't settle on a single number. So if it does not exist, then it diverges. Okay. Then we moved on to series, and we had 8 tests for convergence and divergence of a series. The first test that we learned was the nth term test. And the nth term test told us if the limit of the terms does not go to 0, then it diverges. However, if the limit of the terms does go to 0, this test is inconclusive. We don't know what it does. So if we're looking at this series, we're going to start with the limit as n goes to infinity of 3n plus 2 over 5n minus 1. That is equal, so that's 3/5, which is not equal to 0, so therefore we diverge, okay? All right, so that remember we're looking for our top-heavy and equal equations. So if our equation is top-heavy or equal, then we know it diverges by nth term test. If it's bottom-heavy, then we forget about nth term test and we drop it into something else. All right, if it's a p-series, remember if p is less than or equal to 1, it diverges. If p is greater than 1, it converges. So p, remember, is that power or that exponent. So for this guy, p is equal to 3/2, which is greater than 1, so therefore it converges. Yes, this one diverges, this one converges. All right, geometric is the exact opposite. If the absolute value of the ratio is less than 1, it converges. If it's greater than or equal to 1, then it diverges. So remember, the ratio is that number that's being raised to the n power. So the absolute value of the ratio for this guy is 7/9, which is less than 1. So therefore we converge. Now the geometric is the one that we could actually find the sum by doing a over 1 minus r. So if we start with n equals 0 and I plug it in, then a is going to be 4 and r we've already said is 7/9. So my sum is going to be 4 over 1 minus 7/9, which is 4 over 2/9. Which would be 9 over 2. So that would be the sum of all of our numbers. That's the only one that we can actually find the sum on. The others we have to just approximate. Okay. Then we have the alternating series. Remember, alternating series has 2 conditions, that the limit of the terms goes to 0 and that the second term, the n plus 1 term, is less than the n term. So it's decreasing. So if we're looking at this guy, again, when we think about a sub n, we ignore the -1 to the n, and we have n over n squared plus 5n minus 2. So first condition is the limit as n goes to infinity of n over n squared plus 5n minus 2 is equal to 0, which it is. And the second condition is a sub n plus 1 is less than a sub n. So this one is going to look like n plus 1 over n plus 1 squared plus 5 times n plus 1 minus 2 is less than n over n squared plus 5n minus 2. So that's correct. So therefore, it converges. Okay. Now, remember I've talked about if the terms go to 0, I haven't seen very many where this condition isn't met, so you just assume this condition is correct. All right, direct comparison. Remember, we either said less than a convergent converges or more than a divergent diverges. So if we determine the following converge or diverge. So we're going to compare this to B sub n is going to be the series of 3 halves to the n. And we know that with that guy, the absolute value of r is equal to 3 halves, which is greater than 1. So therefore, we diverge. If I take 3 to the n over 2 to the n minus 6, and I compare it to 3 to the n over 2 to the n, if I subtract 6 from the denominator, I'm making it bigger. So therefore, this guy diverges because I'm more than a divergent. Over here, if we compare it to the p-series, b sub n is going to be the p-series of 1 over n squared. Here, p is equal to 2, which is greater than 1, so therefore it converges. So now we're going to compare 1 over n squared plus 5n and 1 over n squared. Well, adding 5n to the denominator is going to make it smaller. So now we're less than a convergent, so therefore we also converge. Okay. Limit comparison. We're going to do the ratio of the limits. We still need to pick our comparison series, but now we're going to do the ratio of the two series. And as long as that as long as that limit equals to a number between 0 and infinity, then they're going to match. So I'm going to compare it. Remember, we take the largest exponent on top, the largest exponent on bottom. We reduce and we get 1 over n. So I'm going to say b sub n is equal to the series of 1 over n, which is a p-series where p is equal to 1, which is less than or equal to 1, so therefore we diverge. Okay, so now we're going to do the ratio. So we have the limit as n goes to infinity. We take what we were given, which is n squared plus 3n over n cubed minus 4n minus 6 divided by 1 over n. Flip and multiply gives me the limit as n goes to infinity of n cubed plus 3n squared over n cubed minus 4n minus 6, which is equal to 1, and 0 is less than 1 is less than infinity, so they'll match. So what we compared it to diverges, so this guy diverges. Okay, ratio test is the one that you liked. We did the ratio of the n plus 1 term over the nth term, and if that ratio is less than 1, then it converges. Greater than 1, it diverges. If it's equal to 1, then we picked the wrong test. All right, so let's do our limit as n goes to infinity of, okay, so we're going to do 2 to the n plus 1 over 5 to the n plus 1 times n plus 1. Oops, I didn't mean to put that there. Times, now we're going to take the original and flip, so 5 to the n times n over 2 to the n. Now I meant to close it. All right, reducing the limit as n goes to infinity. Okay, we've talked about this before. You cannot reduce polynomials, so go ahead and circle them. The 5 to the n leaves me with a 5 on bottom. The 2 to the n leaves me with a 2 on top. So what I end up with is 2 times n over 5 times n plus 1. That's equal, my ratio is 2/5, which is less than 1, so therefore we converge. Okay. All right. Next, we did the integral test. So we said if you can evaluate the improper integral, then the two will match. The series will match the integral. Now, the series will will be greater than the integral. So if they ask you to compare them, the series is greater than the value of the integral. All right, so we're going to turn this into f of x, which is going to be x over x squared plus 2 squared. And remember our conditions, f of x is continuous, positive, and decreasing. Okay? All right, so now we're going to have the limit as a goes to infinity of the integral from 1 to a of x over x squared plus 2 quantity squared dx. Remember, the bounds on the integral come from the bounds on the sigma. And because we have an infinity, we got to do it as an improper integral. Now, I'm going to do u sub. So u is going to be x squared plus 2. So du is 2x dx, so we need a 2, so I'm going to put a 1/2, and I'm going to put it all the way out at the beginning of the limit. All right, so now I'm going to turn this into 1/2 the limit as a goes to infinity of the integral. I'm going to change my bounds. If I plug 1 in, 1 squared plus 2 makes 3. If I plug a in, I get a squared plus 2. Now my formula becomes u to the negative 2 du, which is going to be 1/2 times the limit as a goes to infinity. Antiderivative of u to the negative 2 is negative 1 over u, and we're going to evaluate it at 3 and a squared plus 2, which is going to be 1/2 times the limit as a goes to infinity. If I plug in a, I get a negative 1 over a squared plus 2. If I plug in 3, I get minus negative 1 over 3. Now, because I'm dealing with limits, if I plug infinity to the denominator, this piece is going to go to 0. So I'm going to end up with 1/2 times 1/3, which is equal to 1/6. So that means that the series, therefore the series, converges. However, it will converge to something that is greater than 1/6. Okay? All right, last thing we did was radius and interval of convergence. So for our radius of convergence, if it was geometric, then remember our r has to be less than 1, because that's when a geometric converges. So for this guy, to get from one term to the next, it looks like we're multiplying by x minus 1 over 5 over and over. So the absolute value of our radius is the absolute value of x minus 1 over 5, which needs to be less than 1. So then we had to solve this. So that gave us negative 1 less than x minus 1 over 5 less than 1. Multiplied by 5 gives us negative 5 less than x minus 1 less than positive 5. Add 1 to both sides gives me negative 4 less than x less than 6. So that is our interval of convergence. Now remember, we don't have to check our endpoints when it's geometric, because our our geometric series test says when it's equal to 1, it diverges. So we don't want it to be negative 4 or 6, because then our ratio would be equal to 1. Okay, next one was the ones that were non-geometric. So when it's non-geometric, remember we use the ratio test and we have to check our endpoints. So let's start out with the ratio test. So we have the limit as n goes to infinity. Okay, if we do n plus 1 term, it'll be x minus 5 to the n plus 1 over n plus 1 times 3 to the n plus 1 times n times 3 to the n over x minus 5 to the n. Okay, reducing. I cannot reduce the polynomials, so I'm going to circle those first. The x minus 5 on the bottom drops and leaves me 1 on top. The 3 on top drops out and leaves me 1, 3 on the bottom. So I end up with the limit as n goes to infinity of the absolute value of x minus 5 times n over 3 times n plus 1, which is equal to the absolute value of x minus 5 over 3. We want that to be less than 1. So now we've got to solve that. So -1 less than x minus 5 over 3 less than +1. So that would be -3 less than x minus 5 less than +3. And if I add 5, I would get 2 less than x less than 8. Now, the problem with these is when I take 2 and I plug it in, that would give me -3 over 3, which is -1. Absolute value of that is 1. And the ratio test, remember, doesn't know what's going on or what happens when the ratio is equal to 1. So we go back to the beginning problem and we plug in. So we're going to plug in x equals 2 into our original problem right here. So when we plug in 2 minus 5 is going to be -3 to the n over n times 3 to the n. Like exponents means we can divide those bases. So -3 divided by 3 is a -1 to the n over n. That's an alternating series. So a sub n is equal 1 over n. So two conditions. The limit as n goes to infinity of 1 over n is equal to 0, and then 1 over n plus 1 is less than 1 over n. So therefore, we converge by alternating series. Okay, now we've got to check our next endpoint, which is at x equals 8. Well, when we do 8 minus 5 is a +3 to the n over n times 3 to the n. Now that leaves me with just 1 over n. Well, that's a p series, so p is equal to 1, which is less than or equal to 1. So therefore, we diverge by p series. So ultimately, what that tells us is that 2 is a good number, that will work, but 8 is a bad number. So it ends up then so that our IOC final answer is 2 less than or equal to x less than 8. So that becomes our IOC, okay? All right, and then remember our center of that guy would be 5 and our radius would be 3 because it's 3 to get from 5 to 8 and 3 to get from 5 to 2. All right, so that is it for the first part of our review. So next class period, we will do the second part of our review, and then we will be done with sequences and series, and we'll move on to something else. All right, that's it, guys. Bye-bye.